Okay, testing, 1, 2, testing, testing. Okay, hopefully all can hear me okay. Non-logarithmic. A little bit different than the calculator. There's the EXP or the EP. Okay. You can see when I press on the E key there, it has 2.7182. I'll try to get rid of some of this lag. Try to get rid of some of the echo in the room here. Make the sound quality better, preferably. Okay. Testing, 1, 2, testing, testing. That should be better. Okay, good. Okay, Edsel, you're really laggy today. You need to like boost your internet signal or something. I don't know. Plugged in. I'm all plugged in. Yep. Okay, perfect. Oh, okay, that makes sense. I see, I see. That's okay. You know what? Actually, just turn your video off, and that'll take less resources on your laptop. So you don't have to have your video on. I'm gonna take attendance, so just either say that you're here or post in the chat box that you're here when I go through attendance here real quick. Okay, Cassidy is here.
Yes.
Alejandro.
Here.
Liliana.
Here.
Lainey.
Here.
Cassandra. Romeo. Diaz. Viviana. Oops. Brenda.
Here.
Jasmine.
Here.
Josue.
Here.
Jade.
Here.
Valerie. Okay, thank you, Valerie. Edsel's here. Joel.
Here. Here.
Monique.
Here.
Salvador.
Here.
Caitlin.
Here.
Kayla. Kayla. Romeo Ramos.
Here.
Paola.
Here.
Aaliyah. Ricardo.
Here.
Matthias. Matthias. Okay, one more time. Cassandra Diaz. Romeo Diaz. Viviana Duarte. Kayla Ocampo. Aaliyah Romero. Matias Vega. Okay, thanks. Okay. Let's go into chapter 7 notes today. Okay, we're just going to cover 7.1 and 7.2, I believe. Yep. Okay, 7.1 and 7.2 today on chapter 7 notes. Okay, downloadable from Canvas. Okay, you do have a project. Maybe I'll go over the project. You do have a project that's due in a week. A week from Sunday. So like a week and a half, like 10 days. So this will be part of your next exam. So half of your exam is going to be the chapter 7 project. Half of your exam score is chapter 7 project, and then there'll be a very light exam, no more than 10 questions on chapters 5 and 7. Okay, so half of your exam score will come from the take-home project, and half of your exam score will come from the very light exam. It's almost like a quiz that you'll take in class a week from today, I believe. So according to the syllabus, is that right? So no, 2 weeks from today. Sorry, my bad. 2 weeks from today. Okay, and so the chapter, so it's not 10 days. It's the chapter 7 project is due October 9th. So it's coming up, but you have more, yeah, you have 2 weeks. 2 weeks from today. So just keep that in mind. Okay, so again, the chapter 7, there is a project. You can start working on the project now if you want to work far ahead. Okay, everything that we cover up to today is what you need to do the project. Okay, the things that we cover next week, yes, well, sort of depends on what type of loan or bank account you're looking at. Okay, for the project, but I would have you maybe look at that you know, over this weekend, just to get yourself an idea of what's going to be expected of you. Do not wait till the last minute to do the project. That would be very irresponsible, I guess is the word, or it would just not be good. So don't wait till the last minute to do this. So again, the chapter 5 and chapter 7 assessment. One is a summative assessment on the project, and one's a formative assessment, which is just basically a quiz. It'll be worth half the points of a regular exam. Okay. Okay. And I'll send out an announcement on Canvas about that as well as it gets closer. I thought it was next week, but it's actually 2 weeks away. Okay, sounds good. Okay, 7.1 is on simple interest. Okay, simple interest here. Okay, it says personal finance is critical when we start to work and balance our expenses. How do we know what we can afford or what we can save? How do we know the mortgage we can afford? How much will we have in our retirement funds when we retire? These are all personal finance questions, and we will eventually need answers as we move into different stages of our lives. Number 1, simple interest. Principal is the original amount of money that is deposited into an account earning interest over time. Okay, so that's the money that you start with. Okay, the interest is the amount of money that is earned, okay, or paid, depending upon if you're the one borrowing the money or if the bank is borrowing your money. the hell? Stop. Go away. Okay. Interest is the amount of money earned. There we go. For maintaining the principal in a financial institution, the amount of interest is determined by the interest rate. Okay. Designated by the respective financial institution. Okay, simple interest. Okay, the interest is for one-time interest. Okay, is I equals P. P naught is the principal. So P naught is the principal. The R is the interest rate, and that's always as a decimal. Okay, the interest rate, you can, if it comes to you as a percentage, you need to turn it into a decimal to do any calculations. Okay, I is the interest. Okay, and this is one-time simple interest. If you do simple interest over more than one period, here's your simple interest formula. It will be I is equal to P times R times T, or P naught. I don't really do the P naught. I just do P for principal. Okay, so I is equal to P naught RT. I just say it's P times R times T. This is if there's more than one interest period. And usually T represents time. Okay. T for time. Okay, so however many time periods, you just keep multiplying. Okay. Okay, and then the amount over one time period is P times 1 plus R times T. This again, I could rewrite this. Okay, if it's multiple time periods, it's A equals P times 1 plus RT. So that's if there's multiple time periods. Okay, so 7.1 here. Suppose a city is building a new children's park and issues bonds to raise the money to build it. Sally obtains a $1,000 bond and pays 3.5% interest annually and matures in 6 years. Okay. How much interest will Sally earn after 1 year? Okay, so after 1 year, how much interest? Well, the interest is going to be equal to the P times the R, the principal times the rate. That's for 1 year because the T here is 1. Okay, so let's find that out. The principal is 1,000 and the interest rate is 3.5%. But what is 3.5% as a decimal? Go ahead and post your answer in the chat box if you know it. Okay, what is 3.5%? What's the rate here that we're going to multiply by? Yeah, thank you, Ricardo. 0.035, exactly. So we're going to take that, we're going to multiply it by 1,000, and we get $35 is the interest that she would make, okay, in 1 year. Okay, $35. Now, what about 6 years? Well, 6 years, I would just multiply this by 6. This is just going to be $35 times 6 years, okay, is going to be equal to $210. Oh, okay. What would be Sally's ending amount? The principal paid with the interest. Well, you just take the principal and we add the interest. And we get $1,210. Now, where does this formula come from that we showed? A equals P times 1 plus RT. Okay, where does that formula come from? Well, if I distribute the P here, this becomes P plus PRT. Well, what is this? Isn't this the interest? That's the principal plus the interest. Something going on here. Oh, there we go. Okay. Okay, so this is the principal plus the interest, which makes sense. Principal, which is the amount that you initially invested, interest. So let's see what happens if I plug in the values for the previous problem. I have 1,000 times, okay, 1 plus 0.035 times 6. Is that going to give me the same amount that I got before? Well, 0.035 times 6 is 0.21. So this is 1,000 times 1 plus 0.21, which is 1,000 times 1.21, which is 1,210. Boom, same amount. So the formula does work. And how did we get the formula? Well, we took the interest. Okay, so we took the principal plus the interest, the principal plus the PRT, and what did we do? Well, we just factored out a P. Boom. And that will be my final amount. A is my total amount. Okay, it's also called my future value. Okay, it's the value that I'm going to have in the future value. The P is called the principal, but P also has another name. So P is called the principal. It's also called the present value. Okay, so A is the end amount, or oftentimes referred to as the future value, FV for short, PV, FV. So if anybody hears, if anybody talks about the present value, well, that's the amount of money that you have on hand today. What's the future value? That's the amount of money that you're going to have in a year or 6 years or however long in the future. Okay. Okay, simple interest over time. We just went over this. This is the simple interest over time. Okay. I just derived that formula for you, so we're all good. Okay. Uncle Moneybags deposits $300. Okay. Earning 5% interest rate. How much will Uncle Moneybags have in 10 years? Okay, so A is equal to P times 1 plus RT. This is just simple interest. Simple interest. Okay. Okay, so what's our principal? What's our present value? Not everybody at once. Thank you, Cassidy. Okay, 300. Okay. Okay. What's our interest rate as a decimal? What's our interest rate as a decimal?
0.05.
Okay, and how many years? Well, that one's easy. 10 years, right? Okay. Okay, so 0.05 times 10 is 0.5. 1 plus 0.5 is 1.5. So this is just going to simplify to 1.5. Times 300 is equal to $450. Oh, okay. So that's how much he will have in the account. Oops. In the account after 10 years. Okay. Okay. Why is it not scrolling? Oh, because I'm using the wrong remote. Okay. A loan company charges $30 interest.
You can bring that.
Say that again.
I don't know if you can hear me, but the last one, you can just bring down the one. So you can just bring down the 1.5.
Yeah, it's just 1 plus 0.5 is 1.5, right? So,
Okay.
right. So
You
it
have
just
it.
gets
Okay.
it gets added to the 0.5 because this thing is 0.5. So you're always going to have a 1 plus some decimal value, which is just 1 and then the decimal. Okay, 1.5. Okay, loan company charges $30 interest for 1 month loan of $500. Find the annual interest rate. Okay. So what's the interest? The interest is the principal times the rate. Okay. Okay, times the time, basically, but this is just for 1 month. We want to find the annual interest rate though. Ooh, that's kind of interesting. Okay, so what's the annual interest rate? Okay, so charges $30 interest. Okay, $30 interest times, okay, we'll do the PRT in here. $30 interest on a loan of $500. Okay, for 1 month. So if I wanted the annual interest rate, I would want time to be in years and not months. Well, how would I represent 1 month in years?
Would you just multiply it by 12 because there's 12 months in a year?
Close. 1 month, I want to change that into years. Well, how many? I would want years on top, and I would want months on the bottom, right? So I would have 1 year is how many months? It's 12 months. So if I wanted to change this to years, would I be multiplying by 12 or dividing by 12?
Dividing.
Yeah, dividing by 12. This is 1 month is actually 1/12 of a year. Does that make sense? Okay. So I can take 500 divided by 12. We'll just clean this up however we want to do it. Okay, algebraically. Okay, so I could say, oh, this is 500 over 500R over 12 is equal to 30. You could cross multiply. You can multiply by a reciprocal, which is probably what I'm going to do. Okay, if I multiply both sides by 12 over 500, then that cancels and I'm left with R. Okay, so 12 times 30, that's 360 over 500. And I'm going to reduce that. Okay, and so 360 divided by 500 is 0.72 or 72% annually. Or I could say that my APR is 72%. APR, what does APR stand for? Does anyone remember?
Annual percent rate.
Exactly, annual percentage rate. Okay, so when you hear all these commercials, okay, to buy a car, which buying a car is like the worst thing financially, and like the way that we shop for cars in America is really messed up. I'll just tell you that right now. Okay, so you should never have to haggle for the price with somebody who knows how to screw you over financially, and that's their job. They're paid to do that. They're paid to basically lie to you. So it's yeah. Anyway, so you got to know this stuff so that when you go in to buy that car that you want, you know, that Mustang or Camaro, whatever that you want. Okay, you got to know this stuff so that you don't get taken advantage of. Okay, in the when you go to buy that car. So because they will. I've studied it enough to know that there's a lot of unethical practices that go along and things that you shouldn't have to pay for that most people end up paying for. So the APR is 72%. That's the annual percentage rate. So again, on the car commercials, when it says, oh, the annual percentage rate is 3.2%, or the APR is 3.2% on this new truck, or it's 5% on this new lease. Okay, then that's what it's talking about. It's talking about you're gonna have to borrow money at a certain interest rate that's paid annually. Okay, and that's the annual percentage rate. So. Okay, compound interest. Okay, compound interest arises when interest is added to the principal. Okay, interest is added to the principal of a deposit or loan, so that from that amount on, the interest has been adding, that has been added also earns interest. So you earn interest on your interest, basically. You're earning interest on your interest, which is kind of nice. Okay, this addition of interest to the principal is called compounding. Okay, so let's see how this works out for us. Okay, let's say that I invest $1. Well, let's do $100. Okay, I invest $100. Okay, at, I don't know, what do I want? Let's do 12%. Will that work out nice? I don't know. Let me think about this for a second. 12% interest? Yeah, let's do 12% interest. Okay. I'm going to take $100 and I'm going to invest that at 12% interest. Or let's do 5% interest. Let's make it easier on ourselves. Okay, 5% interest. Okay. At the end of 1 year, okay, at the end of 1 year, how much would I have? If I took the principal, and well, let's do the interest rate first. Okay, let's do the interest. Let's take our $100, okay, plus the interest, right? The principal plus the interest. Well, how am I going to get the interest? Well, that's just rate times, that's the principal times the interest rate. Okay, so this is $100 invested at 5%. Okay, does that make sense? So this is my principal and this is my interest that I would make after a year. So far, so good? Okay, so what's the principal that we would make? Well, we're going to start with $100. What's the interest that we're going to make? Well, what's 5% of 100? $5. So at the end of 1 year, I should have $105. Does that make sense? Okay. So the way that we can rewrite this algebraically is we can say the 100 plus 100 times 0.05, okay, was really factor out the 100, and I got 100 times 1 plus 0.05, okay, because when I distribute the 100, I get the principal plus the interest, right? So this formula adds back the principal for me. It says, hey, if I just keep a 1 in front, then that's going to give me the principal and the interest. So if I take 100 and I multiply it by 1.05, I should end up with the amount in the account, not just the interest. Does that make sense? So if you do that on a calculator, you multiply 100 times 1.05, you get 105. Right? That 1 there kind of acts like a placeholder, and it says, hey, we're starting with 1% of our $100, right? That 1, this 1 really means I want 105% of $100, which is $105, right? Why do I want 105%? Because I want the amount that I started with, which is 100%, plus the 5%. That is the interest. Does this make sense, kind of? Hopefully it kind of comes together. Oh yeah, we have 100% of our original plus 5% is our interest. Okay, 100% of our original plus 5% of our interest. Okay. So what we're going to do is now we're going to see what happens in the next year. What happens in the next year? Well, I don't have just $100 to work with. What do I have? I have $105 to work with. So I feed this back in. Okay, I go, oh, 105 times 1.05 is equal to what? Let's do that. 105 times 1.05 is equal to 110.25. So I didn't just make $5 the next year, I made an extra quarter. Why did I make an extra quarter? Why did it not just go up by 5 like with simple interest? Because we made interest on our interest. This extra 25 cents, the extra 25 cents came from the $5 previously made, okay, in the prior year. That extra 25 cents came from the $5, not just the principal, okay? So what do you think I'm gonna do in the next year? Yeah, I'm gonna plug all the money that I made the previous year into the system. I'm gonna go 110.25 times 1.05, and that's gonna spit out how much I will have made after the third year. So this is after the first year. This is after the second year. Okay, what's gonna be the third year here? Okay, that's gonna be multiply.
115 and 76 cents.
Okay, perfect. Let's see. Yeah, 0.25. Oh, sorry, 1.025. Yeah, so 115.76, okay, is how much money we'll have made after the third year. And again, I don't just make another $5. If I was doing simple interest, this would just be $5. It'd be 105, 110, and 115. But I didn't. From the first year to the second year, I made an extra quarter. From the second year to the third year, I made almost an extra 51 cents. Right? So the amount I'm making every year kind of goes up. Compound interest is so much better than simple interest. Okay. Well, let's get a general formula for this. Let's see. Let's get a general formula for this. Okay. So let's start with our $100, and then in the first year, what did we do? What did we do to get the first year? Well, I multiplied by 1.05, right? Well, isn't this just going to be my 105? And what did I do to that 105 to get the second year? Didn't I just multiply it by another 1.05 to get the second year? Wouldn't this be my 110.25? And then what if I wanted to get the third year? Well, aren't I just multiplying that previous result by the next 1.05? And wouldn't this be 100 times 1.05 to the third power? What do we notice? We notice that that after the third year, that's the same as the power. That's kind of cool. So if I wanted to find how much money did I have in my account after 10 years, what would I have to do? I just go 1.05 to the 10th power. Does that make sense?
Yeah.
So go ahead and calculate that. How much money is in my account after 10 years? Should be a good sizable amount. 100 times 1.05 raised to the 10th power.
162.89.
Yeah, exactly. $162.89 is in my account after 10 years. Does that make sense? So far, so good. Okay, so let's generalize this to a formula. A is equal to P times 1 plus R to the T power. That's for annual compound interest. This is annual compound interest. Okay, is this guy here? Okay, for annual compound interest, that's that guy there. We just take their principal times 1 plus whatever the rate is, and then multiply it by T compounding cycles. Okay. Okay, let's use this. Okay, let's use this to solve 7.4 here. Okay, I think we can do that, right? Maybe not. Oh, this is compounded monthly. Never mind. Let's go back to, let's describe what would compounded monthly look like. Okay. If we compound monthly, so monthly compound interest, we would have to take our, I can't spell, interest. We'd have to take our annual interest rate, our APR, which is equal to R, and we'd have to divide that by 12. Because we're compounding monthly, which means that there are 12 compounding cycles in the year. It means that every month I'm compounding, but I'm not compounding based on the annual rate. I'm going to compound based on a monthly rate. So I have to cut this down by 12. So we get A is equal to P times 1 plus R over 12. But if I'm compounding monthly at a smaller rate, that means that I'm compounding 12 times faster. So the number of compounding unit increments will be 12 times T. Okay, so say that I compound monthly for 2 years, okay, at 6%. Okay, compound monthly for 2 years at 6%. What would that look like in my formula? Well, I would have to go, oh, this is going to be 1 plus 0.06 over 12 raised to the 12 times 2. Why? What does this 12 times 2 represent? 12 times 2 represents 24 months of compounding. I would go through, after the first month, January, I'd compound. Second month, February, compound. Third month, March, compound. I would compound a lot more frequently, but I would be doing it at 1/12 the rate, which is what? What would be the interest rate, monthly interest rate here? We have an APR of 6%. We have an APR of 6%, which would translate to a MPR, a monthly percentage rate of what? Well, take 0.06 divide by 12. 0.06 divide by 12, I get 0.005, which is 0.5%. So this is my monthly interest rate as opposed to an annual percentage rate. So I'm going to compound this thing monthly at 0.5%. Oh, okay. So this is going to be A equals P times 1 plus 0.005. Okay. And let's say that we plug in our $100, our same $100, 0.005 raised to now the 24th power. Now, the number of compounding cycles, right? So again, if we look at the year, January, February, March, April, May, June, July, right? So what am I doing? I'm compounding at a smaller interest rate, but then I'm compounding again, and then I'm compounding again, and I'm compounding again, and I'm compounding. And I'm doing this, instead of doing one compounding unit over a year, we're doing 12 of these cycles in a month, but at 1/12 the rate. This is R, and this is R over 12. Does that make sense? Hopefully that makes sense. Like you're cutting down the rate, but you're cycling a lot faster. So we do 24 cycles in 2 years instead of 2 cycles in a year. And what does that allow us to do? It allows us to make more money. Okay, the more times I compound, the more money I'm able to make. Oh, okay. So what would this come out to be? I don't know what this comes out to be. $100 compounded at 1.005 to the 24th power. What does that come out to be? 1.005 raised to the 24th power, and then multiply by 100. And I get $112.72. Okay. Okay, what if I had just used simple interest? What if I had just used simple interest? Well, let's say that, what if we had just compounded twice? What would that look? What if we just did our annual compounding? How does that compare to just annual compounding? Well, the interest rate would be 1.06, right? Squared. So did I make any more money by compounding more frequently? That's what I want to know. So 100 times 1.06 raised to the second power. Yeah, I have 112.36. Ooh, nice. So compounding annually, I made 36 cents less. Compounding monthly, I made 36 cents more. Okay. Does that make sense? If I didn't compound at all, if I just did simple interest, okay, so this is compound monthly. This is compound annually. And this is simple interest where we don't compound at all. Well, what would we have made? We would have made $100 times 1 plus 0.06 times 2. This is going to be 1.12, which is 112. Okay, so this is even made 36 cents less again, okay, than compounding annually, then compounding annually, but I made 72 cents less than compounding monthly. So I'm really losing out, okay? The more times I compound, simple interest, I only made my flat 6% every year. They only paid me 6% on my initial investment every year, boom. Compounding annually, I actually get to make money on my interest, so I made an extra 36 cents. Compounding monthly, I get to make interest on my interest on my interest 24 times in a year, or sorry, 12 times in a year. So 24 times in 2 months, and I made an extra 36 cents. Okay, so the more times I compound, the more money I'm going to make. Okay, let's go back to the example over here. It says 7.4, sorry. Uncle Moneybags gives nephew starving actor $2,000 to deposit in a savings account, earning 3% interest compounded monthly. Okay, so this is compounded monthly. How much will the actor have after 20 years? So the principal is, the amount is equal to the principal times 1 plus R over N. We say N is the number of compounding increments times N to the T power. N would be like your monthly. How many times a year are you compounding? Well, N would be 12 in this case. Okay, so what is the principal? It's 2,000. What's the interest rate? It's 3%. How many times am I compounding a year? 12. So it's 12 times the number of years, which is 20. Okay. So this becomes 2,000 times 0.03 divided by 12 is 0.0025. So this is 1.0025 raised to the 240th power. Ooh, that's nice. Okay, so just plug this into a calculator. We get 1.0025 raised to the 240th power. And I'm going to multiply that times 2,000. Okay, and I get $3,641.51. 3,641.51, I believe, yeah. Okay, so I'm almost double my investment. Okay, by compounding monthly here. How much interest did he earn? Well, we just take the total amount and subtract the amount invested. So take 3,641 minus 2,000, and I get 1,641.51 in interest alone. The power of compound interest, my friends. Okay, let's do another example here. Okay, 7.5. Professor Smart wants to save $20,000 for his newborn son, Child Genius's college education. Okay, well, good luck. Okay, if an account earns 5% annual interest, and he anticipates his son to attend college at age 16 years old, how much should Professor Smart deposit today? Okay, so it's just doing annual interest here. So annual interest means that we have A equals P times 1 plus R over N to the NT power. But N in annual interest, N is 1. N equals 1 for annual interest. Annually compounded. Lainey, can you mute yourself? Thanks. Okay, N equals 1 for annually compounded interest. So this just becomes our original compound interest formula, 1 plus R to the T power, right? Okay. So how much is he going to invest today? What's the present value? Oh, no, we don't know the present value. That's what we want to find out. How much should he invest today? That's the present value. We do know the final value. The final value is $20,000. So that's the final value or the future value. Present value, I don't know. What's the interest rate? The interest rate is at 5%, 1 plus 0.05, and it's going to be invested for 16 years. Okay. So I have 20,000 is equal to P times 1.05 to the 16th power. Let's divide by 1.05 to the 16th power. And that'll cancel that out, and that'll tell me what the principal is. So the principal is 20,000 over 1.05 raised to the 16th power. Okay, which is going to be approximately something. So let's plug that into the calculator here. Okay, so 20,000 divided by, okay, I'm going to do parentheses, 1.05 raised to the 16th power. I'm going to close my parentheses. Okay, and then I'm going to hit equals. Boom. And that's 9,162.23. So about half. He needs to invest about half, little under half, to meet that $20,000 mark in 16 years. But hey, he only needs to start with half of the money, less than half the money, and he's going to get, in 16 years, he's going to have he's going to make basically twice what he invested. So half of the money will come from what he has saved, and half of the money will come from interest, which is great. If you can get the bank to pay for half of your college, that would be great. I wish I could do that. Wish I had done that. But I didn't have wealthy parents, so I had parents that were not wealthy, were not mentally sane either. So, hey, you get what you get, and you don't throw a fit, right? Okay. Okay, what'd you miss? What'd you miss, Edsel? $7.5? Do you have a question on this last one, Edsel? Or was it the last one? With simple, with all the comparisons. Oh, okay, yeah. It's over here, right? Boom. This one here? Good. I know. I get excited about this stuff when I start talking really fast. Again, keep in mind that the stuff is on YouTube. As soon as I end class here, I try to post the stuff on YouTube as soon as possible. Okay. Okay, that's it for the notes for today. Okay. Make sure that you're working on your homework, and I will see you next Monday. Okay. And I'll post an announcement about the Chapter 7 project sometime over this weekend. Okay, thank you. Thank you for being so awesome. Okay. Yeah, you too. Oh, Kayla, I think you came in late. I'm going to have to mark you here. So if you did come in late, let me know.